Today we're going to be taking a look at the law of cosines. And I know some of you are probably out there thinking, why? Why? We have plenty of rules and regulations here, lady. In fact, we already have another law, the law of sines. I can't believe we possibly need another one. But yes, we do indeed need another approach to some of these problems. And this is why we need this other law of cosines. And let's take a quick peek at the example we're going to be working on, just to show you why we need this new law of cosines. Here, we're given an angle A, and we're given sides B and C, and we want to find the rest of the information for this triangle. However, A is 120 degrees. We don't have any 90-degree angles here, so we can't use the Pythagorean theorem. That's not going to work. Also, we have angle A, but we don't have side A, so we're not able to establish that ratio that we would need in order to use the law of sines. So if we didn't have this handy-dandy law of cosines, we wouldn't be able to proceed with this problem. I know some of you are thinking, so what? We couldn't do it. But yes, we are going to be able to do it. Let's take a look at what this law of cosines states. And here you can see there are three different versions of it. They all say the same thing. They all are expressing the same relationship. They're just shuffled around depending on what angle we have in our problem. So what I want to do first is take a look at this last version here, where and I'm going to cover this up for a minute, and we see we have c squared is equal to a squared plus b squared. Well, that's the Pythagorean theorem that we know and love. So our law of cosines starts out looking like the Pythagorean theorem. C squared is equal to a squared plus b squared. But now we have this additional term in here. If this was indeed a right triangle where C was the hypotenuse, then we know this angle C opposite the hypotenuse is 90 degrees. The cosine of 90 degrees is 0. So 0 times this minus 2ab thing would just be 0, and we would simplify to our Pythagorean theorem. So if you want to think about it, that this law of cosines is kind of a very fancy Pythagorean theorem where it starts out with the sides of a triangle squared plus the opposite side squared, and then you have this additional term of minus 2 times the length of those two sides, now multiplied by the cosine of this angle that's opposite here. So that's the difference in all these. In this first version, we have angle A on the right, so on the left side of the equation is the side of the triangle A. In this version, we have angle B on the right, so on the left side, it's the length of side B. How are we going to use this thing? One way we're going to be needing to use the law of cosines is if the information we're given is two sides of a triangle, but now the one angle we are given is not opposite either of these, because if the angle we were given was opposite either one of these two sides, we could use the law of sines. Because the angle we are given is not opposite, but it's included between the two, then we're going to be having to use this law of cosines. So the general approach when we're given two sides of a triangle and the angle that's in between them, not opposite either of those sides, is first thing we're going to use the law of cosines, and we're going to find that missing side of the triangle. So now we'll have all three sides. We only have one angle, so we're going to need to find two angles. We're going to find the first angle by using the shorter of the two sides, and we're going to take the shorter of those two sides and use the law of sines to find its partner angle. And then the last step you're going to find pretty straightforward. Now that we have two angles, we're going to be able to find the third angle simply by subtracting from 180. In this example, as we took a quick look at, we're given angle A is 120 degrees. We're told side B is 7 and side C is 8. So we can't use the law of sines because we can't create a ratio. To start out, I'm just going to write the formula. In this case, because it's angle A that we know, on this left side of the equation, it's going to be its side that we're going to have. So we're going to have side A, and now it's the two other sides of the triangle squared minus 2. The two sides of the triangle from here multiplied together times the cosine of angle A. So let's put our information in. We don't know A, so A squared just sits there. Side B, we can see it from the picture and also here. Side B is 7, so we have 7 squared. Side C is 8, so we have 8 squared minus 2 times 7 times 8, and now times the cosine of 120 degrees. A squared is, we have 49. 8 squared is 64. 2 times 7 times 8. This is going to be 112 times the cosine of 120. I'm doing these calculations, showing you in a couple of steps so you can follow along. When you do these, you might want to put all of this on your calculator at once. That's fine. Be careful how you enter it. And I highly suggest, rather than you just sitting there watching me do this, grab your calculators now and do this calculation yourself on your calculator to make sure that you get the numbers the way you should, that your order of operations are good. So finishing this statement here up, when I add these and then subtract these out, we get that A squared is 169. We don't want A squared, we want A. So taking the square root of both sides, we have A is 13. So now we have all three sides of this triangle, A, B, and C. We only have one angle, so we need to start finding the other two angles. Because we have solved for side A and we now have that, I'm going to use my law of sines, and I'm going to use A, just to remind you about law of sines, over the sine of A. So in this case, we're going to have 13 over the sine of 120 degrees is equal to, so there's our ratio, 13 over the sine of 120. And this is going to be equal to another side over another sine of an angle. So we're going to look for the shorter of the two sides. So B is not greatly, but it is a little bit shorter than C. So I'm going to make this ratio here 7 over the sine of B. As usual, when we do these, we cross multiply. 13 sine of B is equal to 7 sine of 120 degrees. Dividing both sides by 13, we get sine of B is equal to 7 times the sine of 120 degrees. I don't know why I keep forgetting that one, all over 13. So sine of B is approximately equal to, if we do this calculation, 0.4663. And now we don't want the sine of B, we want B. So we take the inverse sine of this and we get that angle B is approximately 28 degrees. Now, we don't have to worry. Remember with the law of sines, we said, okay, this could be from Q1 or Q2. We don't have to worry about this in the law of cosines because we are taking the shorter side. That's always going to be an acute angle. So we don't have to worry about rummaging around in Q2 for any other possible angles. So when we get our angle here, we're good. And we use that for our B. Now to finish this up, we can make the statement that the angle we were given, so we have 120 degrees plus 28 degrees. The missing angle at this point is C, plus C is equal to 180 degrees. And when we solve this for C, we get 32 degrees. So we have all three sides and all three angles. So the law of cosines, we start with the law of cosines, but then we also have to use the law of sines.